share. So for intro purposes, this is the South Sound user group, and Matthew is going to present on the GraphSQL, or sorry, GraphQL. My bad.
Yeah, it's just GraphQL. Okay, let's see I'm sharing my screen. Okay, so I have Slack and I have my outline open here, and mostly what I plan to do with this is going to be kind of similar to my previous talk on generative art, where I have some code, some examples. I'm also going to walk you through GitHub's GraphQL API and kind of touch upon a whole bunch of different things. For those who aren't familiar with GraphQL, what it is that it's sort of an API query language that is runnable over HTTP, but it could take on other mediums as well, meant for typed data, where the data types themselves have a sort of graph-like relationship. This is not like a graph database similar to, say, Neo4j or anything else where the entities have a graph relationship that tends to be more ad hoc and freeform, but this is more like, say, a relational database where if you have a blog and you have posts and you have comments and you have authors, and there's a relationship between those, it is more of a way of creating an API on top of that type of data structure. The data itself that comes back is typed based on a schema, and the relationships are defined in that schema. Two of the things that I like about this is it makes it a lot easier to evolve an API over time, because what happens is a query specifies the data that the client wants, and the server will return that data and only that data. It doesn't return anything extra. So if you have a field that has a certain behavior, and you need to, for a new novel purpose in the next version of your awesome website, you need a different version of that same field, you can just add it, and all of your existing clients will be fine. They aren't asking for that field. They might not even know it's there. But for clients in the know, they can ask for that field and get that new behavior, and it doesn't penalize any of the old clients. You don't have to, that way, in that manner, it's a lot easier to evolve your API and not have to version it. The other thing I like about this is that it reduces the, I have here, it reduces the request load of network edge clients, particularly mobile, to gather the data that they need to construct their view. In this manner, like a lot of web pages or mobile apps that I've worked on, for a particular screen, it might require data off of 2 to 8 tables out of, say, a relational database. And in like standard strict REST semantics, that might involve making 2 to 8 calls, perhaps one for each table. Maybe based on how sophisticated the API is, I could reduce that down a little bit. But almost certainly, in the process, I'm going to be getting back data that I don't need. And so in this manner, what this API allows for is reducing the data that gets sent back and forth, particularly when it's gzipped. Queries are declarative in that they specify what is wanted rather than how to get it. This is a rather large query here that I have, and I have effectively pasted it into GitHub's Explorer. I can post a link to this in Slack. It is signed in. I'm signed in as myself here, and I'm running this. And what I'm doing here is I'm asking for, on a particular user, of a variable name, which just disappeared. Login. So let's say on myself, I want to get the login name, the data that they provide as a URL for my avatar, my website address, maybe we're going to get the first 5 open issues, and on that, we're also going to get the total number of issues. We're going to get some information about pagination, so I could say scroll over to the next pages. And then on every issue, I want to get the title, did I author that issue, information about the author, including their avatar, and on what repository that issue is on. That's just here. And then we're also going to get on starred repositories, we're going to get, in this particular case, these are ordered by when the particular repository was starred. I want to get the first 5. I want to get the total number of stars. I want to get some pagination information so that the client can scroll through it. And at the same time, I also, on every repository, I want to get the name, the URL, the description, how many stars it has, who owns it, what the labels are, and let's say the total count for the watchers that are there. Similarly, I also want to get information about the first 5, or just the people that this user's following. Same thing. I'm going to get the total count. I'm going to get some pagination information, and on the user that is being followed, I'm going to get some of their information, including how many repositories they have, and the first 3 repositories for all that. That's a lot of information to get in one query. If I want to effectively say, okay, let's cut this out, and well, okay, it is clearing my login. If I want to remove that starred repositories information, it doesn't bother going to get it for me, and that's just not there. If I need the information in a slightly different shape, let's say I want to go old school and call this, it would be useful if I could type, call the login handle. I can, it is clearing my login, my variable here. You know what, I'm just going to remove that variable. I can tell it that I want to rename a key in the process of having it come back. So I can't maybe transcend objects or arrays with that particular renaming facility, but it does make it useful in terms of working with legacy data. And so, first of all, I'm going here and I'm getting all this information in one go. I have not necessarily told the server how to get that information. I've left that up to the server. I've just said, here's what I want. Please get it for me. And I tried to translate this into like what this might look like in your typical REST API. I'm going to get information about the particular user. I'm going to get, say, some information about their issues that they've created. On each issue, I need to look up the user and the repository. I'm also going to get that user's starred repositories. And then on each of those, I need to look up some other stuff. Then I also need to look up who they're following. On each of those people, I need to look up their information about their repositories, and then information on each of those repositories about the particular stargazers. That is a lot of requests for my little dashboard screen, to the point where like I might run into rate limiting issues, or I might run into just like other issues about getting data from the network. And at the same time, like I've said here, hopefully this includes pagination info. Some of the APIs just in the process of putting together the example data that I have for the server that I have locally. For example, I went to try to wrap a Mastodon REST API client, and the pagination facilities are different for every type. Some types they include it in the header, sometimes they include it in the body in a hypermedia style API. And it was very disconcerting to work with, and the how really got in the way here. So, pagination is one of those things that can be a little bit tricky at times, but you can hope that it's consistent, but I have yet to meet a API that handles it comprehensively and consistently. Also, these two particular items here, I just want the count. So I'm saying first equals 0, but I mean, like, you know, does this API give me a way to say, well, what are the counts there? And then, you know, also like here, this thing here, states equals open. This is the filter information that we're hoping that they've exposed through the URL. And my experience with query variables in a query string is that they break down really quickly, and it's hard to form an expressive thing there. So while this kind of thing might be easier to implement on a server, it makes it much more difficult, I think, for a client to come up with a comprehensive manifest of the data it needs. Here, because the data has been, you know, because the GitHub has put a lot of effort into making their schema really good and having this all be very performant, I can have this go and get it, and it will come back to me in, I think this is responding in probably 500 milliseconds or so. I'd pop open the query panel, but I'm afraid it might expose my like authentication token or something. And let's see. So the other thing that I like about GraphQL here is that it's introspective. There's a very heavy emphasis on having published schemas and documentation around it. This tool here, GraphQL, is just it's a web page IDE that you can attach to any schema. I have done this for all the projects that I've worked on. I've put this on top of it. There is a documentation browser where you can go and look up the particular queries that you might want for something. You can hover over any particular item in a query here and see, like, okay, this is an issue connection. What is up with an issue connection? Or this particular nodes here is a user. What is available on user? And I can go get that. And there's a little bit, you know, there's some description, some information about the types for particular objects or functions or what they are and whatnot. And that has enabled a lot of really good developer tooling. It also makes it really nice to say, validate that a query is valid. Like if I were to put this in as, say, not a string, I get an error back. The argument login on the field user has an invalid value. We expected a string. If I swap out, let's say login 3, I ask for an invalid field, it will tell me that. If I am putting an argument in here that doesn't exist, that's not valid, and so on and so forth. As I will show you a little bit later, a lot of that validation stuff comes for free in terms of hooking up to the server. The schema has defined that these are the valid, you know, in terms of the issue connection here, there are actually, in terms of the issues field on the user, there are certain arguments that are allowed. And if an argument isn't in that list, then the schema knows that, oh, hey, that's invalid, and it will handle sending back this error message for me, which I think is really nice. You know, also, in addition to tools like this, there's editor integration. There are things where you can build, you can do code generation to build, say, a type system from a schema. Particularly if you're working in TypeScript, there's a lot of really good tooling around that. I'm probably going to be working on one to generate types from a schema for Golang pretty soon. And I think that in terms of just being able to introspect on the query and on the schema, it allows for a lot of great stuff. So there's some really kind of basic stuff here at first. You've got some basic types. You have objects, which, let's see if I bring this back to normal. You know, user is an object. query is actually an object. If I go all the way back up here, query is an object, and these are fields on query. Similarly, mutation is an object, and mutation works a little bit differently, but I'll get into that. Roughly in a particular schema, the object is your basis for a type, and that's where the relationships come in. It has fields, and the fields can be roughly one of another different type. They can be another object, as say, let's say this code of conduct field, which is a field that takes arguments, but it returns a code of conduct type. If we go to back over to user here, there's some good stuff here. A field can be a regular kind of scalar value. You've got your string, your float, integers. There's a fun one called ID, which is it simply means it's an opaque string. I'll show you here. Oftentimes these are base 64 encoded, and just as a way of like, don't concern yourself with what this value is. Just when you need to refer to this particular thing, this is what you use it for. And like a lot of times, this is simply this simply will come back as like user, some database ID or something like that, or some UUID. But the ID type is not meant to be human readable. It's just an identifier for something in a system. You can have the custom types. You can also have custom scalars. I think, let's see here, avatar URL. So URI in this particular case is a type, but this is a scalar type, not an object type. And they have defined this as a valid URI compliant string. I have in my schemas, I have put in scalars as like URIs, email addresses, timestamps that are in one of the common things here. So it looks like they have date time as a scalar, and a whole bunch of other things like that. And really, it just like a scalar is, it can be any kind of JSON type. It could be an array, it could be a string or whatever. That's kind of up to the schema definition to define what it is. You have enums. In this case here, open is an enum, and so issue state is open or closed. Field in this case is an enum, and this is star order field, which that is the only type of thing it is. Let's see, it looks like on repositories for order by, we have repository order field. You can order by one of these particular types. And if I were to replace this with an invalid value, I get an error back saying that that is not of the right type. But the ID also will say, give me nice autocomplete information around the enums as well. Let's see, push.. I'm not querying for the push.timestamp here. There are also in the particular schema, you can also define optionals and lists. So some of these types here in the definition have an exclamation point after it. That means that that value will definitely be there. If the exclamation point isn't there, it means that the value might come back as null as opposed to an empty string, or in Golang what they call the zero value or the null value or whatnot for that particular type. Also in arguments to fields as well, if I were to query issues, the pagination stuff is optional. Labels is optional, but it is a list because it's surrounded by square brackets. And inside of that list, the thing itself is required. I can't have a list of null values in there, but I could have a list of strings. Similarly, if I had I think actually on this root query user field here, it's specifying that the login argument is required. If I leave that out, that's an error. There's a whole bunch of other things that the type system kind of gives you to play with in order to give you more flexibility. Actually, see here, there are interfaces, which are a way of saying, like, this user implements all these different interfaces. Here, this following, I mean, this is, it says it returns a list of users, but I think there are some fields that would require, but I have to very specifically say here that because I guess this, oh, I don't know what's going on there necessarily, but you know what, for example, anything that implements the actor field, which includes organizations or whatnot, these fields will exist. And so if I wanted to say on actor, well, okay, maybe on one of the other fields where that is very specifically a thing, I can say go ahead and grab these fields, and that would hold true for all these particular types. Really, this is more of a way of saying that these particular types have kind of something in common. If you've worked with a language that has sort of a interface-based inheritance system, I think Clojure has a pretty good way of, it's kind of analogous to Clojure or Elixir or even Golang's interfaces in terms of like saying these are some things that these particular types or whatnot have in common. This thing here with the ... is a way of saying on you. It's what's called an inline fragment, but I can also just say fragment user details on user. This is a way of not repeating myself. So on any user I want, avatar, URL, and URL, and then I can user details on that. And also here, I could just replace this with user details. And so this is a way of, for any particular query doc, saying, giving you a way of not repeating yourself. There are union types that you can have as well. So for maybe a collection or a particular node, you can say that maybe it returns one of multiple types. I don't know of one in the GitHub API off the top of my head. I had picked one out and I can't remember it anymore. But it's a way of effectively saying it can be one of this, a way of combining multiple object types into another object type. I think pinnable item type. No. Let's see, pinnable item connection. Oh, here we go, pinnable item edge. So pinnable item here can be a gist or a repository. This is, that's just another, or that's a union type and a way of getting a collection of things that could be one of multiple types. There are input types as well, which is a way of passing a bunch of arguments to a field like this or to a mutation, which I'll get into a little bit later, where rather than, let's say, go back to user here and let's see, I think pinnable item type is an enum, but if I wanted to, oh, I know, we have order by. So gist order here is an input type, and it's effectively a way of tying together both the field and the direction that they have. And I don't know, that it's just a way of allowing you to specify, have a more rich way of providing arguments to functions without having to have like order field and order direction as separate arguments to the particular field. I've tried showing off variables earlier and it kept getting blown away, but if I wanted to declare a variable on this query, I could say login of type string, And then I would, okay, I can type. What that does is allow me to create a schema that I can copy and paste. I can actually just use without having to do any kind of string interpolation. If I wanted to say include some other things in that particular variable set, it erased it again. That is not nice. Let's say I want to get issue count int, and we're going to use that here. Then I can also, I can do that again. And say I got one issue. And it comes back, and there it is. Another thing that that you can do as well is operations. So I'm going to call this one user main screen, and then let's see, we'll get another one here, which will be query maybe user minor screen login string, and we're just going to do user details. Any fragments that are defined in a document have to be used on every operation that are in the particular, forgot to define that. This fragment, because it's defined here, if I do not use that fragment in every operation that's provided in a document, it's considered an error. And I think the idea behind that is to prevent people from just copying and pasting large documents around the internet that aren't for a specific schema. But now when I go to run it, I can choose which one I want to run. Expected value not to be null. Oh. And at that point, when I send this document off, this allows me to have a whole bunch of, effectively one particular thing that I send to the server and whatnot. The other thing that are provided are mutations, and I can show you that real quick. This is a way of, I had in my description of the talk, I said that I think that GraphQL provides a good foundation on which to implement the query command query responsibility separation pattern. And mutations are why. So for a query, the other thing here that I can do too is I can on query, so I can do multiple things. I'm only getting the user here, but if I want to, for example, oh, I don't know, what is what's somebody else's GitHub login? Let's see.
He's mine.
All right.
EMRAGINS.
I'm sorry.
EMRAGINS.
Okay.
There hasn't been much recent activity, so I don't know how interesting it will be. Should
Okay.
probably use fields or something instead.
Well, we'll see. Oh, expected. Variable. Oh. Okay. Now I have a valid query again. I can get multiple. So this is another thing too. Here is I'm getting multiple details in one go. But so then for a mutation, and according to the specification, these lookups can actually happen in parallel. These are not ordered necessarily. They don't have a particular order. But a mutation, on the other hand, will say this needs to have a definition. What is a mutation I can do on a user? Update issue. Can I do do just scan for user in here, unfollow user. Here we go. So presumably there's a follow user input. All right. So I have mutation follow user. This is going to be, it's going to call the actual function follow user. I can do multiple. I could do multiple mutations in here. So let's see here. This returns a follow user payload, but let's see, user ID and an optional string. Oh, so it has to actually be a. Okay, I'll put ID in here. Get this. And then, I don't know, presumably, I'm going to comment this out. Okay, so now I have some IDs. Okay, I can mouse tonight. Input, okay, this is going to be, wait, all user input, user ID, okay. And let's see here, what was the, turns a payload, returns that particular user. And then we'll also do, okay, and then when I run this, it will follow both of you and return the information about you from that particular thing. And it does these in serially, in sequence. So it does this operation first. It waits for that to finish, and then it does this operation and returns that particular data. And now if I go in and run this again, and fix my variable things again. And actually, I'm just going to do this entirely. And I run this again. You should be, yep. And I think I was already following Phil, but yeah, there we go. And so these are the commands that are that you execute. One of the things that I like about this, as opposed to doing puts or posts or whatnot over a traditional kind of REST API, is that I don't have to concern myself too much with the how. This tells me what I need to provide, and it tells me what I'm going to get back. You know, it tells me that, okay, for the input, I have to provide a user ID. I can optionally provide a mutation ID. I will get back that mutation ID and the user that is being followed. I don't have to concern myself too much about HTTP status codes. I don't have to concern myself too much about the semantics of put or post. A lot of times, the particular payload or the particular input payloads for a mutation are constrained to like mutation-specific inputs. I think that GitHub uses some sort of generator to do these on a one-off basis. Their type system here doesn't have a whole lot of things that are well factored. I think that there's a lot of one-off input types here, but for this merge pull request input, auto-generated input, they're using some sort of code generator here. Like this might be a type in there, or this might represent some sort of database record somewhere. It might not. But this particular set of input are what they have deemed to be, here are the things we need to do this command that you want to do. Change user status input. There's like you could say that because all these different types are optional, this is equivalent to an HTTP patch where if one of the fields are missing, then you don't update it. But I know that a lot of people get caught up in the semantics of, oh, well, you're doing a post, everything should be there, and if something is missing, then it gets deleted, and because it's the whole document. And not having to worry about that, having this actually kind of enforced in the and documented as part of the schema, and knowing that, like, okay, well, if this is missing, then it's probably not going to set it to null. I could probably set this to blank.
Sorry, if you don't mind, a quick question.
No, go ahead.
You said previously, like, a lot of these types look like they're auto-generated. Is that a common thing? Because I felt like when we were doing our schema early on,
probably,
like the interfaces and stuff only worked with like response types and not for input types.
Well, that is true. I mean, so for example, this schema document that I have here for the code that I'm going to go over a little bit later, I wrote this out like this, and it will generate all the necessary code from this. I could write that code myself.
So you're compiling the schema from a separate,
no, I write this, and it will generate the code for me. And in actually at my current project at work as well, which is a Going GraphQL server, I am basically maintaining a similar document to this, and a code generator gets run over that, and it will. It's a third-party library that I actually would recommend if you're doing Going stuff, called GQLGen. But you provide it with a schema document like this, and it generates all the necessary Go types and interfaces and whatnot that you need to do to handle it.
Yeah, I was thinking more like limitations in the schema format itself, where you're just kind of missing interfaces. And
I don't know if you can have interfaces on an input type.
No, I mean, like, you can't, and that like, we started thinking about, okay, we need something that does support, we need a richer format to declare our schema, because the GraphQL only compile to a GraphQL. Unions don't work in inputs either.
I think I without knowing your specific specific issues, I'm hesitant to comment on it. I think though that for a lot of things, they have this code, and they have this larger, higher level declaration, and I think that is a common thing to have. And then they're generating, they're not generating a document like this from it. They're generating Ruby or JavaScript or whatever GitHub is written in these days from that, and so they have this, they have this change user status input, and then they're like kind of thing, and it was just easier to do these kind of one-off things rather than try to think about how to fit together. You have these specific inputs and specific responses, and it was probably just much easier to define each of these individually rather than try to come up with a richer scheme, particularly around mutations, to come up with a richer way of saying don't repeat yourself.
I have a kind of corollary question, if that's okay.
Go ahead.
I mean, maybe you'll get to this later on, but like, at what point in, say, your development process would you think about defining or like instantiating GraphQL or the schema? Like, is that usually before or after you do the database, after you decide your operations? How does that relate to the UI? Like, where do you actually figure out what you want to do with it?
Well, I think that also depends on where your project is and its maturity. In my case, for my current project, it is replacing a lot of kind of ad hoc REST endpoints. One of the things that I'm trying to do is use actually use input types and whatnot to provide a sort of rich searching system for performing fairly sophisticated queries, and so I'm trying to kind of construct a grammar for doing filtering. But the actual data types were pre-existent, and you know, in terms of the things that are being returned and the things that are being queried on, those were pre-existent and ultimately defined by somebody other than me, even for new things. On a project that, actually one of the main projects that we used GraphQL on at my previous job, we had decided to use it early on in that project and not kind of bolted on after the fact. But the process of going through and defining the schema actually informed how we shaped our data to begin with, and I think that helped a lot. That sort of feedback loop around, like, oh, okay, well, you know, we need to return a list of these particular types. Hey, that sounds like a union. And going back and forth. In that particular project, my role was kind of a bridge between the front-end web, front-end mobile, and back-end server people. And so for that, this like coming to an agreement about the structure and schema effectively of our data proved to be, I think, a very useful conversation to have.
Okay.
Yeah, let's see here. So, because you have a schema, you know, I think I showed you a lot of the validations that you have earlier. There's a few rules. You know, the field must exist. If I ask for a field that doesn't exist, that's an error. If I go and ask for a field, let's say I do this one and I don't ask for any fields, that is an error. That's actually a hard error. It's not, you know, oh, hey, there's a language problem there. Let's see here. You can't select fields on a scalar or enum type value. So I think, let's see here, yeah, this is the field ID. You can't make a selection on that. Arguments must be valid. I showed you that earlier. And this is a good one here. Fragments cannot refer to themselves or create a cycle. So you know, I can have multiple fragments on user. Let's say I want to have, let's say, how many people is that particular user following? Okay, I'm just gonna bunch of stuff out of my query doc here. Wait, no. User, so this is going to be and we're going to return this as follow count info. So I could tie that fragment in here. I'm getting that follow count info there. I could, you know, also put this fragment in up here, rather. But if I were to say put user details in here, that's a no-no because I've created a cycle. Like very specifically, oh, hey, you created an infinite loop. And again, that validation should come with whatever server library you're using. So it's something that you get for free. Oh, and the server will enforce the type system, the optionality. One of the things that I like about this is, you know, I know that as somebody who's writing the code that's handling the resolver for this following field or this, you know, whatever thing where I'm getting the login field here, the schema is enforcing that that's a string. I don't have to worry about that. The optionality is enforced by the schema and by the server library because I have declared login as because login is being declared as required. That is something that the server harness can do for me, and I don't have to worry about. There are, I think, a few things where you might want to have custom validation. For example, this pagination thing that they have here is a way of saying I want both the, what I'm saying here is I want both the first 5 and, oh, not after 5, and the last 5. I can type, really. I want both the first and last 5, but that doesn't make any sense. This is validation that they have probably written themselves, I'm fairly certain. And in my own APIs, I've written this too. I mentioned the introspection and the documentation stuff. This is going to vary depending on how a scheme is defined. In the interface that I'm going to show you later, this is how I'm putting documentation. It's a string before a particular interface. For introspection, there's actually all this information here about the query and the documentation and the type system and whatnot. There's a way of just querying the schema itself to get the lists of types and to get the lists of enums and the values and the lists of scalars and all the documentation and all the relationships. And I don't want to get into that because it's neither here nor there, but for example, on any particular type, you can ask for the _type name field, and it will tell you the particular node it is. There's a very heavy emphasis on having things documented and having things introspected, and it makes the tooling, I think, a lot nicer to work with. There's a couple of patterns that exist in this world that I want to touch on really quickly. There's a common pagination pattern that was defined in the relay spec, and this is completely optional for people to implement, but it's something that I have decided to like, and it comes down, or it's something that I like and have decided to implement in my APIs, and it comes down to having first, last, before, and after, along with this page info and has next page and cursor stuff. So if I get rid of my fragment and I get rid of, let's say I get rid of all that, and for my particular screen here, I have the list of people that I'm following. I can also do query, we'll say follower page. And we're going to go with, it's always going to be a page size of 5, but we're going to have after string. And I'm going to go with, let's see here, user login. This is still going to be on me. Following first 5 after that. This is what the cursor looks like. Cursors can be a little bit complicated, but they are a way of doing pagination that doesn't involve offsets. The main reason behind that is if you want to page through a collection of things and be sure that, where the number of things in that collection can change over time, cursors provide a way of setting the boundary. So this particular page, for example, has it has a next page, and then that is the cursor for the last item on the page. And we'll just go with user details here. Oh crap. Oh wait, that's right. Nodes. Yeah. So I haven't defined my after variable, but if I do, oh wait, hold on here. I'm also going to do page info. So I'm going to re-execute this one. I'm going to get that end cursor again. Re-execute this, and then I get the next page and other people that I followed. And then from here, if I wanted to continue on to the next page, I get even more people. And if I wanted to say have ability for has previous page, has next page, and start cursor. I can get all this, and then from here I can also, we'll just say, we'll rename this to bound, oh no, after string and before. Well, I'm just going to rename this to before. So what I'm saying here is now I want the last 5 that are before this particular cursor. I like this pattern of pagination. Well, okay. That returned an empty collection. Let's see if I redo this one. Have in cursor. I'm not going to get into it too much. What this pattern of pagination does, though, is provides a nice way to go back and forth across a series of a series of items in a collection where the contents of that collection might change between requests without overlap or gaps in the contents of the pages. Every item in this particular collection has its own cursor, and I could query that if I wanted to. I'd have to use a slightly different way of grabbing it, but I could say, okay, well, here's my point. Let's say it's the last thing that the user saw in this particular collection, and if I wanted to re-grab the collection from there, I could. I'll get into cursors a little bit later too. They tend to be tied to a particular sorting method. There's also another thing that's also completely optional called the global object ID. And I mentioned earlier the thing about interfaces. So user implements a node interface. Node has one particular thing called ID. If I wanted to have query get node, and we're just going to go ahead and grab this ID. And this is a union that it's going to return, but it's a way of saying on any particular thing, grab that. If that node happened to be something else, I could say on repository, go ahead and grab the ID and I think it's the name. It's a way of saying whatever this is, I don't care what it is, whatever it is, go ahead and look it up for me. It's another thing that I found to be worth implementing because it is very useful for just looking something up. Two other things I want to touch on before I get into my demo. I'm not going to delve too much into these, but there are there's a thing called directives where, let's say I have if I don't provide this before, I can say like, I think it's if no. Okay, it's a way of another way of avoiding string concatenation. It might be actually easier to look at that here on the documentation site. This is a way of based on some variable that was provided to the query, switching out the information that you're querying for. So most servers would implement include and skip. I've seen a couple of other directives that are being included. I have, in my particular schema that I've implemented, I've created a directive here to tie into a library around gauging the complexity of a query, which it's another concern about implementations. There's also extensions that you can do. There's Apollo is a very popular library for doing serving and acting as a client in the JavaScript world, but they have a tracing extension that I don't remember. Yeah. What this allows you to do, what this does is provides a specification for what it does is, this is effectively its own little schema that is, in addition to data and errors, you can say, hey, let's get some information about how this particular query was executed. And for complex queries, this can be a real lifeline in terms of doing some debugging, particularly across distributed systems where it's like, oh, maybe I have to pass this 3 or 4 services away in order to get the information that I need, and something went wrong somewhere, and I want to find out where. You can expose tracing information through this, and it's pretty useful. And it's something that you can turn on or off in, say, development. There's one of the built-in extensions to the official JavaScript server is better error messages, where it gives you a stack trace and everything. And that's about it for my discussion of what it is. In terms of how, consuming it is pretty straightforward, so much so that, like, at my previous job, I actually ended up writing a blog post on this that I actually kind of turned into, like, I'm kind of surprised by this, but this has gotten a lot of traffic since I wrote it. The gist of it is that these are just HTTP requests for a particular, this particular simple query. This would be the curl request that you have, and I went through what I think what variables look like, how to send a request with variables. It actually would just kind of look like that, where it's just JSON data. You have a query string, you have a JSON object that gets passed along. Operations, you'd have an operation name in here as well. You can use a library to handle this for you. I don't know that you necessarily need to, but ultimately it's just data that's going back and forth across the wire, often over HTTP. If you can figure out how to map an API schemas to your language's type or data system, that is kind of the hard part. For my current project, one of the larger challenges is just like taking data that is naturally represented as a union and trying to fit it into Golang, which doesn't have unions, or data that is naturally represented as an enum, and same thing, the language doesn't have enums. The other aspect of like it's just data is that I said here, success is often granular. So let's say on this query here, let's say let's say the information about users and the information about followers and the information about repositories were all stored in separate things. And the users was up, and so therefore following was also up. But let's say the information about repositories was down, and we can't get, let's say we can't get the information about repositories at the moment. Since the repository connection is empty, but since what is it? I guess nodes here is guaranteed, but no, it's not even guaranteed. So if nodes comes back empty, we can also then go and check our error messages to see if, like, oh, hey, errors is down, repositories is down right now. Here's the information we were able to get for you. So you can display information about the user, but where the repositories is, maybe you want to display a little error message. And that is, for pretty much everybody that I've talked to about implementing, like actually putting this into implementing their interface, it just seems like a foreign concept at first. What do you mean success is granular? I'm used to getting like a 400 back or a 500 back when something breaks. And if I get data, then great, it's all good. And you don't have to implement a particular server that way, but you could, and I think that you should. And likewise, it just encourages you to think on the client side about, okay, well, what if I have this data that I wanted, but not this other data that I wanted? How can I handle that? I don't know. I think error handling is one of the most underrated hard problems in programming systems. So it doesn't make it more complicated. It just makes it more nuanced.
That's really cool. I'm curious if there's a pattern, or as just kind of an accepted standard for detecting. You know, and I'm thinking more from like a validation standpoint, I guess. So this might apply more to like mutations, but if there's a standard pattern for detecting an error and then translating that to the user. So I'm thinking, probably a lot of the responses from a GraphQL API are going to be not user readable, and so that
right.
And so
Well,
how do you? Yeah, sorry.
So
go ahead.
so okay. So these error messages come back in a particular kind of thing, and typically this means like I made an error with my query. However, there's nothing preventing. Let's say, I don't know. Oh, there is a user foo. Okay, let's find some. Okay, note to self, I can't type super fast on my fancy keyboard because it will turn into modifiers. So let's say maybe this user doesn't exist. They're telling me here the user was not found. We could not resolve to a user with this. In an API, if I were designing this API, this would not be an error. It's just the user doesn't exist. The fact that it is null means that the user doesn't exist, but they're choosing to put something in there about an error. There's not really a standard around that. I think, I've worked in more dynamically typed languages for most of my career, and so the idea of having a null represent a missing value just feels natural to me. I know that null is the $1 trillion mistake or whatever, but how else are you going to represent nothing, right? On the flip side, there's an entire possibility here, let's say for repositories to say.
Well, I'm noticing that there's the not found type there, which I guess potentially you could.
Yeah,
detect.
Here's what I would do though. In the case, let's say the repository server is down, you've got this repository connection type, and you can say like, oh hey, for this is information about a collection of repositories. I would put an error message on here. Repository. If this is a point of failure, if I know about my system and how the data is all put together and this isn't just about the types and how they relate, but how the actual implementation of the data and its relationships work. I know that the crossing over from a user to a repository involves translating across data systems. I would put a field on here that said, load error or some sort of thing like that, indicating that, oh, hey, this is, we had a problem. And it would be nullable, and you could check on that. Or another thing that I've done is just have union types where error is a particular type in that response. Or in mutations especially. One of the things that I do in the API that I've got now is if you've got a mutation that you submit, you have to handle both. You've got a success. It could return a success, or it could return an error, and you can just have fragments for that. So this would be like, let's say that if this were on a particular different type, it'd be on error instead. And this isn't valid in the particular schema here, but if it were, it would look something like that. And so in the client, I could say, okay, well, the type name is an error, so therefore I can switch over to my error handling version of it. Yeah. So okay, another one. I was trying to use the variables thing here, and it kept getting wiped out every time I typed something in up here. But avoiding string concatenation and string interpolation for your queries and using variables is just it is big. It allows you to put these queries in their own text files with something and load it into your runtime, or have them as strings in your system that don't involve any kind of thing. It allows me to copy and paste it to something like this IDE editor here and run it with variables that are separate. And it allows me to play around with it a lot easier, and I think more intuitively. It is it's a I don't know. I don't particularly like cleverness, and my experience with trying to do like I actually did try early on with working with this to have dynamically generated queries, and there are some libraries that will help you do that, but really just don't. It's not worth it. There are two kind of heavyweight clients for the JavaScript world. There are some others. You probably don't need to use one, but if you do, they're there. Relay is the original one that came out, and Apollo is a popular one. They handle some other things for you, like automatic pagination. So if you've got a one of these, I didn't actually get into it, but if you've got one of these connection types with where it's named connection and it has edges, and the edges have a node and a cursor, and the field that calls the connection takes this first, last, after, before kind of thing. What that allows you to do is what Apollo will give you then is automatic pagination for forward and backward. It will handle some caching stuff for you. I use it in one of my projects. It's kind of nice, but if I were, I mean, it's also internal tooling. If I were doing it on, some front-end website where performance was key, I would definitely be more into using its caching facilities. Okay, now the fun part. I'm gonna close this off, and I have a little server running locally. I took out, I found some data actually from Stack Exchange. This is on the Internet Archive. You can download a periodic database dump of one of the Substack exchanges for as XML files, and load them up. And I had to include the license file because that's what the license says. But this is for the Conlang subreddit, which I have a minor interest in. And the data is in XML, so it was really easy for me to just load it up into some JavaScript objects. And I was originally going to do something a little bit richer on top of this, but ultimately settled on having users, questions, and answers, and badges for the users. And so I pasted the link to the GitHub for this, the GitHub repository for this into the Slack channel earlier. You can download and run this yourself. This schema type, or the schema definition here is rather, I don't know, it's 250 lines. And it's not as well documented as I might like, but I'm pandemic parenting, so my time is kind of not what it used to be. I've got some type definitions here. I've got some custom scalars around email addresses and timestamps and whatnot. I've got a directive that I'll get into a little bit later. I've implemented the pagination spec page info kind of things here. I have some input types that I'm using for filtering and whatnot. And when I load up the server, it will go ahead and read in this file and build a schema from it. I set up an app. I have some stuff around effectively attaching the data to the request context, but I'm going to switch back over to the, no, I'll just keep it here. Typically, you would I also have a custom error formatter for the built-in extension, but typically you just put it on a endpoint, set it up with a little server responder, pull in your schema. Your schema. I'm telling it also to give me the GraphQL IDE out of the box, and resolvers is just in this case it's a JavaScript map from a package here, and this handles my root level resolvers that are being specified for the query and mutation objects here. So I've got 3 root level queries. One is looking up a single user by its ID, looking up searching for questions and searching for users. I've also got one mutation around adding a badge to a user. The data's all in memory, so there's nothing particularly exciting there. You can poke your head into query.js if you want to see some really kind of ugly attempts at writing functional JavaScript code. And this is kind of how I would go about setting up one of these schemas for this. So I have, like, I want to look up a particular user here and get some of their information. What questions have they asked? How many answers have they given? And so, it's returning, like, in this particular case, user by ID. I could rename this to just simply user. Oh, return. Oh, that didn't like that. Okay, well, that's fun. I found a bug. But what I was going to talk about this. Oh, so I'm using I'm using the official JavaScript server implementation. There are a lot of server implementations for a variety of languages. Don't bother writing your own if one already exists. Just contribute to it instead. I will personally vouch for the Glycinia library for Clojure and GQLGen for Golang. They've both been very nice to work with. The official one for JavaScript is, I don't know, it has a lot of problems that are consistent with all the problems in the JavaScript ecosystem. I'm not a huge fan of JavaScript, but I'm using it here because I think it's perhaps one of the better languages for demoing things in. So you might ask, okay, how do we, we've got this user, we're doing get user. How do we get that data? So I'm gonna make things a little bit simpler, and I'm just gonna ask for the display name and reputation count off of here. I'm gonna go into my resolvers, and this file's a mess for a number of reasons, but this particular thing here, user by ID, is the function that's being called when I handle that. It's calling up with the arguments that are being provided to the query, or the field on the query object, and the request context. I had attached my data to the request context. Ordinarily, this is also where you would attach authentication information, database connections, etc., that you might need. It's just a JavaScript object. I think that's actually the express request object or whatnot. But I pulled this out to a separate function for reasons I'll get into. But I'm just going through the array of users, looking for the user that has this particular ID. And I'm calling this prepare user function. If we ignore questions and answers and badges for now, you can see that all it's doing is renaming 2 fields and returning the rest of the data that came out of the XML file for that particular row. It doesn't matter that I only asked for display name and reputation. It's just returning everything. In this particular case, it's also returning the badge information. But that is, I'm just returning everything that there is there for that particular record, and that is what I would call immediate eager resolution. The badges are done in the same way. I get my list of badges. In this particular case, I'm just finding, what I'm doing here with this lookup is I'm showing that it is calling user by ID one time and badges by user ID one time. I'm going here through all the badges in my data, looking for the user ID that's being asked for, and those are my badges. That happens regardless of if I ask for the badges or not. If I rerun this, I'm not asking for the badges, I'm not getting the badges, but it's still calling that function. It's still doing that work. And that's nice when your data is simple or when the request is simple, but that, it doesn't, this lets the library handle things like, oh, they're not asking for the created field. They're not asking for the last access field. They're not asking for the badges field, so I don't need to do that. But it's easy for me to get, so I'm just going to give it anyway. And all the things like, say, renaming this to handle, that is done for me by the server. I didn't have to write any code to get that facility. I didn't have to write, if I take out reputation as well, I didn't have to write any code to make that not happen. I was going to talk, yeah, so I mentioned the context thing here. Typically, you want to deal with any authors. You would probably handle your authentication type stuff up front. One of the services that I handle in production, I have things on the query field here that require you to be logged in, and some things that actually you need to be logged in. And so in that particular case, for my root level resolver here of user by ID, like I would, if I wanted to ensure that the user was logged in, I would handle that here and throw an error if they weren't. I could say error. Oh, I can type today. And this might look like something like so now that is a protected field, and it's giving me an error message back. That's something that can be done in one of the middleware that happens before. Similarly, like the context would get passed along to get user, and this is my business logic here, for lack of a better term. But if I wanted to ensure that my logged in user could only look up users they could see, I would do it in the business logic layer. I don't know, a lot of the more complex kind of database systems that I've worked in will typically pass around a context object of some kind that has things like information about the user, what their authorizations are and whatnot, and you just kind of do a similar thing here. So let's see here. Okay, the next thing I was going to talk about is type level resolvers, and this is where I'm getting into fields that take arguments. These don't have to be fields to other types, but just any field that takes an argument. If I wanted to have a variation on last accessed where it returned, say, like 5 days ago, I could, or maybe allowed me to specify a format string for the time. I could do that here. Typically, this is in the JavaScript version, I'm effectively assigning a function to this particular thing here. And this is returning, this is a function, it actually is a function, I think, that returns a promise. But if I user answers, if I run that, and because we didn't ask for answers, it's not executing that function. So this is not being eagerly loaded right now. It's deferring it until I ask for that particular field on the user type. And now, since I did ask for the answers field, you can see that it's doing it there. In this case, I'm having to handle the same arguments context, and there's another one here called info that are being passed in, and I'm just passing that off to an answer search or question search. In this particular case, question search is also, it's the same resolver that I'm using on my root here to look up questions. It's just adding a particular user ID. So if I want to find the particular questions that this user's answered, passing in some arguments and some fields and whatnot, and running this, it's deferring it over to the same function that is resolving things for down here under search questions, just using effectively, let's say, I think my user ID up here was what, 112, yeah. User, oh, hey, I've got another bug. Okay, well. Wow, okay. It is a user-dependent bug. We got some fun bugs. It is the same function that's being called. So I have two effectively searches here, and these are making use of input types. And these are also, in many cases, using deferred loading. And I think actually user search has the juicy bits. I have some things here set up to define how the users are sorted, but this is my user search resolver. I am doing some things here to effectively turn the page, the arguments related to pagination into a kind of a common form. It also, I think, does, no, I want to go to, oh, fine. Let's go over here and page args. If I provide a first and a last, this is my custom error handling around the impossible scenario of asking for both ends of a page. Yeah, cannot specify first and last page arguments. But let's say I want to search through my users. I'm going to also kind of ignore their questions and answers. This whole thing is something that I just evolved over the course of working on the talk, but I'm getting 5 users. And in this particular case, I haven't specified any filters, but I have decided that I'm going to sort by a question count. So this comes in here. I'm turning this into a kind of base information about the first and the last, and I'm also setting a sort of default sort. In this particular case, I've set it to created. I'm doing some stuff with the filter that I'll touch upon next. And then I have a kind of generic function to create one of these connections, one of these things that has, this particular case, a total count, some information about the page. And then I have a list of predicates that are set from the filter. I'm giving it the information about the cursor. So in this particular case, we're sorting by question count. And let's see here. Question count says based on a user and a context. What is it? Let's get the, go through all the posts, find the post type 1, so they're questions, with the owner ID of this particular user ID, and return the length. And then this final true argument, Boolean argument here, is just to invert that so that the highest count goes first. And that just, it returns a comparator. This gets used as a comparator for sorting in the query connection. I don't want to get into that particular function. It's kind of messy and whatnot, but it's more of an abstract way of doing this kind of data filtering that is very similar to the type of stuff that I do on top of SQL. I also have a prepare function. This is the same prepare function that we used before for the get user ID. In this particular case, I'm wrapping it up with a context first so that I can access other data. So from two things from here, I got my input arguments around the filter. I'm using the JavaScript functional programming library called Ramda here to do a bunch of things that might actually have been easier to write in plain old JavaScript. But I've defined a number of filters on my input type. So like I can say, okay, on my reputation, why am I not? For any particular users, I want, must be using a different version. It's not giving the mouse over stuff. So for my user filter, let's say I want a user that has a reputation. In this case, it's greater than 100. Oh, I didn't document this. That's why. Or I want a user who has a website URL. I can go ahead and do those, add those conditions to the filter, and this is just a way that I have this might be like the where clause of a SQL query or whatnot, but I just have a way of define a way of composing predicates here for saying this user must meet this condition in order to be part of the collection. You might also note that the total count up here will change when I set these numbers as well. So let's say I want users with a reputation greater than 1,000 that don't have websites. There are 12 of them in this Stack Exchange. If I also want to say that they have the badge of teacher, well, that goes down to 7. If I don't care about this, and so on. The total count is, it's information about the aggregate for the connection. I think, no, okay. What did I have next? Oh, so the, where was it? It's up here. The questions and answers, these are loaded in a deferred manner, but basically these functions get called if the client is asking for them, and I don't have to figure that out myself. Again, the server library handles that because it knows that this is a function that is on that particular key for the object that's being provided to it. However, one of the things that can come up in this sort of environment is, let's say I've got my questions, and I'm going to remove my author ID filter, and I'm just going to, let's say, the first 5 sorted by the highest score. I'm asking for a bunch of stuff on here. I'm asking for the author information. I'm asking for accepted answers and unaccepted answers. And then on the author itself, I'm also then recursing back into their questions. In this case, just information about the sum total of them. But for the questions, this right here, the question to author connection, that is sort of n+1 problem where if I did that poorly, if I did that in this manner where it was deferred loading of just looking up the user by the ID and I reused, say, this, I would run that, well, in this particular case, let's say I ran user by ID 14 times in the course of running this query. That's why I had the lookup. We can ignore the badges right now, but if I go back up here to prepare questions, so, okay, here we go. This is eagerly and directly loading the user. It's, I'm not hiding it behind a function. Now, if I don't query the author and run it, it is still calling user by ID there. It's not getting some of the other information, I think, that was there, but, oh, wait, no? Oh. Okay, well. There's another thing. This came out about the same time as GraphQL, I think, to assuage a lot of the fears. This is another library called. This came out as it was published as a library. It's more of a pattern around loading data, very specifically called data loader. And it was a pattern that came out. It was published around shortly after GraphQL was published to kind of abstract the idea behind taking data. I need to load this thing with this particular ID and get something back. It is not unique to a particular implementation, but the general idea is that you have a you would call a loader function, and that will batch loading. It will batch a whole bunch of those that get loaded. In the JavaScript implementation, what it does is it just takes all of the users that were asked for in a particular frame of execution, and then afterwards it kicks off loading all of them. In this particular case, I have on my context, I've set loaders. This is defined a little bit further down here. I have batch users by ID. So I have, I think, down here I have loaders user by ID, I'm creating a data loader where it calls this function based on the number of keys that are being provided to it. The keys are a variety of user IDs. In this particular case, I have to return a promise, so I'm mapping over the keys. For every key, I'm supposed to return the thing that it would be resolved for it. So either the user object, or in this, if the user wasn't found, null, in the same order that the keys were provided in. So in this case, map is a very, wide answer, a very good pattern for it. But if I were using a SQL query, this might look like getting all the users with the IDs in the particular keys, and then mapping over the keys and finding the one in the particular set of rows that were returned, and putting that in that spot. So if I were to, if I had a keys of, say, 1, 2, 4, 1, 2, 5, 8, 3, I would return user 1, user 2, user 5, user 8, and user 3, and whatnot. I would have to return them in that order. I did not organize this very well at all. But if I resave this and I re-execute this query that I have over here with the data loader, instead of calling user by ID 5 or 14 times or whatnot, now it still did call user by ID 5 times, but it also called batch users by ID once. So what was that before? Did that get saved? Oh, I'm using batch somewhere else. Badges by user ID, batch users by ID. I don't know what's going on there. Oh, oop, that was getting eagerly loaded. Okay. Oh, and I forgot to, that's why things aren't working. Okay, batch users by ID was loaded once. If I don't do that, then it will, it's loading user, it's calling user by ID 14 times there in the course of resolving this. Whereas if I use the data loader, that's right. So get user by ID, I think. Now it's not calling get user by ID at all, and it's instead calling batch users by ID once. So it's rolling effectively all those queries up into one operation. I can also, because this is still being done eagerly, whether I ask for the user or not. If I hide author in this particular case and rerun the query, it's still calling that, as you can see here. But if I hide that behind a function, so it's deferred, and I comment that out. Let's see here. There we go. Oh, I guess it's still loading. Oh, it's loading it here probably. And now it's not loading at all because I wasn't asking for anybody's name. And that's data loader in a nutshell. I think it's a nice pattern to work with for kind of simple belongs to style relationships. You don't have to return an object. You can return a query. The thing is that you can't pass anything extra along to load. So if I had, say, if I had some sort of arguments that need to be passed along, I wouldn't have, say, questions by user ID where I need to maybe pass in filtering options or whatnot, because only the key gets passed in, and that's it. If I wanted to try serializing all the arguments into a key, I could do that, but at that point, I think just is creating more problems than it's worth. What did I have next? I think Yeah, it's ultimate. Okay, ultimate. It's a very simple pattern. In my outline here, there's a pretty good write-up that I think describes how it works. There's a list of implementations of this in other languages, though that list is incomplete. Um, it's a pattern that I recommend if this is something that you are seriously evaluating. It also, like, if you have, let's say you've got some data that's in a store like Redis, some data that's in a store like PostgreSQL, and some data that's in, some sort of, I don't know, Cassandra or something, where it's more of a key value store. It's a good way to abstract those interfaces behind a particular thing. Again, it's also saying, I want this thing. I don't care how you get it. But just, go do it. You figure it out. The final thing that I wanted to talk about with regard to getting into resolving is query selections. And this is clever, but in a good way, I think. So, I have this query that I am handing off here around the questions that I want, the data that I want about those questions. I want the accepted answer, I want the unaccepted answer, I want the author or not. And and with this kind of method of deferred loading and data loader, it's a simple implementation around just go get the thing, and maybe it's making a little bit of extra work. But there's another way you can do. You can decide how to optimize your work, and that's looking at the query being performed, oftentimes called the selections. I'm using a JavaScript library here and a little kind of JavaScript class to abstract over that. This is almost a direct mapping of a structure that I've created in my other work. But the basic idea behind the selections is that you're looking at the info object that's being passed in here from the query. This is very specifically information about the query you're operating in. I'm getting all the paths on that. I'm also getting its path. At that particular point, I'm walking through and just cutting it down to a particular thing. So if I were to selection, if I save this, rerun this, it will show all the particular paths for the fields that are being asked for on that query. And in my prepare for the argument to the connection, I am passing in, effectively, I'm going into Edge's node. So I'm looking at the actual question object itself. So those are the selections that are being made on the question. And then up here, I'm asking, okay, if this post is answered and the query is selecting accepted answer, then let's go ahead and find that answer. I was lazy here and decided to just grab it out of memory. Let's find that answer and prepare it and assign it directly. So in this case, it's a way of doing deferred. It's not a way of doing deferred work. It's a way of conditionally doing the work. Getting prepared, getting answer for question. So let's see here. Yeah, so that's happening there. But if I don't look for the accepted answer, if I comment that out and rerun it, it is not doing that. Same thing here. I'm looking at accepted answers, and I again got lazy and decided to just run the. Oh no, this is doing the same thing as I was doing elsewhere, where it's calling answer search, but just assigning a particular field that's being passed around. This is actually, I think, incredibly powerful. I have in the project that I'm dealing with in my work right now, I have some rather large SQL tables, oftentimes with very, very large JSON objects as fields on them. And for a lot of use cases, I don't need that data. I don't need to grab the entire JSON blob out of the database. But what I do need is 10,000 rows. So if I don't select star off of that table, if I just grab the fields that I need and I don't need the JSON blob field, I don't have to ask, I don't have to tell the database to go fetch it for me. And it cuts down on the query time tremendously. Similarly, this particular library doesn't let me do it, but you can also look into the info object here and look at a particular node and see the arguments that are being provided for it. So on that JSON blob, I'm leveraging PostgreSQL's JSON operators to provide a way to get a subset of the data being asked for, or a subset of the data in the JSON field as a value. So it would look like, it might look like something like accepted answer. Well, I don't know. I actually don't know what it would look like in this particular case. Let's say, no, I don't know. If this were, let's say if badges were a JSON type field instead, and I just wanted to grab, I wanted to have a filter on it. It'd be kind of analogous to that. But what I'm using that particular selection / reflection capability of the query for is to effectively build up the data that I'm extracting out of the JSON blob field from PostgreSQL, so that instead of grabbing the entire, potentially megabytes of data for the thousands of rows that I need, I'm grabbing just the subset of it for those rows. And that, it's sped up the queries a lot. It reduces the amount of data that goes over the network a lot. It reduces the load on the clients a lot because all this data is not being passed around. And ultimately, if you want, you can kind of poke through here. I had another pattern that I have where I'm passing this with all thing into the connection. In this particular case, it allows me to say, like, I had, what was it? Search users, I think. Oh, yeah, on these questions, I was like, for all the users' questions, let's say I wanted to look at the total score. It's just a way of, this is something that I did off of the, all the, similar to total count, where it's looking at all the number of questions that were asked. This is just adding up the scores for all those questions. It's a way of getting information about the entire collection and not the individual records. It's another pattern that I've found helpful in kind of like, how would you do that? Anyway, I'm almost done here. One final thing here, there's this directive that I had promised to get back to. This is, I pulled in a library, and this is a way of saying, defining complexity. This is just what I'm saying here is, okay, I have a directive called @complexity. It takes a value of int that's required. It can be defined on field definition and input field definition. And I've said, okay, this complexity, this has this amount of complexity. And then this gets used in this JavaScript library that I pulled in to have validation rules on the query being performed. And it is looking at that complexity and adding up the scores. I'm saying, okay, I can't do complexity. I'm not going to let you do a query with a complexity over 4, or over 40, or over 100. And if I, oh, well, that's not working. If I execute this and look at it, I have a complexity of 58. If I were to lower this down to 10 and re-execute it, I would get an error back. Too soon. Query exceeds the maximum complexity of 10. So this is another way of not simplifying the amount of work you have to do by effectively saying you're asking me to do too much work. It's not something that I've had to implement myself yet, but it is a common concern when people, I've talked to people about GraphQL. It's like, oh, well, people can ask for anything. What's going to prevent them from, doing a denial of service hack against me? I would think about, the validation already prevents recursive fragments, so they can't do an unlimited depth query. But this is a tool that I see talked about a lot for, preventing a client from asking to do too much work in one go. I might think of it like rate limiting, but you're limiting the work performed, the complexity of the work performed, not how often the client can ask for something. So finally, I've been working with this for about 4 years now, almost since it came out, and really think about your data. And how it relates to it. Don't just, it's very easy in a REST paradigm to simply throw up a collection and say, okay, well, I'm going to, make a REST endpoint to get all these and to put and take and whatnot. And I think there's a lot to be gained from taking some time to actually think about how your data relates to each other, what the natural form of the schema might look like. And all that. It has, in the opportunities that I've had to use it to shape the data, the schema of data, I know it has been a very beneficial process. The documentation, document, it just, this tooling, I didn't do a very good job with this, but if I look at my question connection here, this information is available to me because I wrote it. I know what this means. But if I wanted to present this to somebody else, this is information that they are getting for free through the documentation that I'm providing. Optionals are, I kind of went through this data that I got from the Stack Overflow dump and just looked at how many did or did not have a particular field, how many records had it. Every record had a reputation field, so I made it a not optional field, but there's a reason why these are considered optional by default, where they are nullable, and that is another powerful thing. It allows you to say, hey, I might not be able to return this field for you, or there might be no value there, and you should handle that. On the first GraphQL project I worked on, we had one of our clients was one of our client apps was being written in TypeScript, and they didn't like that at first because they didn't know how to actually use optional types in TypeScript. They wanted me to return empty strings for no value. But yeah, if something can go wrong in that field, if there's no value in that field should be nullable. Let's see here. Big thing. Think about your naming patterns up front. The edge and connection kind of pattern of naming is something that's done in the community. But if I also wanted to, this accepted answer is just the name that I had to come up with. Same with unaccepted answers. And this is not something that is returning this is returning a connection. This is not. And you might not be able to gain that, you might not be able to glean that from the connection. It seems to be a hard problem because naming is a hard problem, but just even going through the GitHub GraphQL schema, they haven't really solved that problem very well either. But it is something that I feel is worth thinking about and trying to come up with up front, because I have I have run into, I wish that I had named this, let's say I wish that I had named this unaccepted answers connection or whatnot, because if I just wanted to provide easy access to, let's say, recent answers, then where it didn't take any arguments, it wasn't a connection field, it just returned a bunch of the answers directly instead of on a connection object, then you know, like, oh, how do I know if that's a connection or not? I can look at this, I can look at the particular kind of type system, but having that reflected in the name is kind of handy at times. And mostly it's been on the connections versus not connections where that's been the biggest issue. Finally, because you are not returning data to a client if they are not asking for that data, this allows you to really evolve a schema over time and therefore avoid versioning, which is, I think, a really big draw. If you're going to have a long-lived public API with lots of clients, the fact that you can say, okay, this score field is going to be an integer forever, you know, for the life of our concept of what score is. If you later introduce some more distinct kind of idea of what a score is on a question where it's taking in, you know, it's not necessarily representable as a number, but you still are going to provide the numeric score, you can add that later. And only the new clients who are aware of it will ask for it, and so therefore only they will get it. So as long as you do not change the behavior of the field, you don't have to version your APIs, which is, again, it gets back to why naming is important. But you know, if this accepted answer is always going to be an answer and not the union that I created between, you know, let's say it could be a comment instead. Let's say there was a union for that. If this is always going to be an answer, then this needs to stay that way. If you have some new concept where you have like accepted thing where it could be some other type, introduce it as a new field, and that allows you to have clients that are, you know, to support backward compat or support clients with a much better and greater backward compatible capability.
A question about that.
Hey, go ahead.
Is there a way to mark things as obsolete to phase them out? I know
There
like
is, actually.
That's like I like
Yeah.
to do is.
There is, and I didn't get into that. I should have, but I didn't get into that. I don't remember. Let's see here. Deprecated? There is a way to do this. I don't remember what it is offhand. It's not coming up in my search of the documentation.
Okay, but it is there.
Yeah, it is there. I think it's a directive, or not a directive, but maybe I think it is a directive. But it is like, if I were to go back over to GitHub's, well, I'm not gonna do it right now.
I say, do you know if it just automatically pops up like a warning on the client?
Yeah, well, like in the tooling like this, it won't necessarily. I don't think it won't come back here, but in this tooling, it will come back as a thing. So if I wanted to, let's say, on my oh, I didn't get into my mutation implementation, but it was really simple. Let's say on my user by ID, I want to. I think it's deprecated. Let's see. I don't know if it will. All right. So I go into query here. I have deprecated fields. Show deprecated fields. This is built into the spec.
Oh, cool.
So
okay.
yeah, it's telling me right here, hey, this user by ID, it's deprecated. It's no longer supported. It might go away. If you're using it, good luck. And there's also a way to like query the particular schema for all the things that are deprecated as well. Like you can the facilities around that are pretty powerful. That's what I got.
Cool. Thank you.
Yeah, I'm happy to take other questions. Like I said, I've been working with this for a while. I really like it, and it has really changed how I think about API design.
That's awesome. I'm interested if anyone else has used it or played around with it, and if they've run into any issues or you know, immediate gotchas that were, yeah, things.
You're on mute, Phil.
We've been using it for about 3 years at my work, and there's some issues around some of the type system features not being very expressive around sharing, like abstracting away data. Like I mentioned some of that earlier. It's like, it's kind of felt like a drag for me because I've only been touching it from the server side. And so I don't have a lot of patience for putting up with just this weird stuff where I'm not getting any benefit from it. I think like this talk kind of helped me understand that, you know, if I was doing both at the same time, then I would probably be a lot more appreciative of some of these features. Because for me, it's just like, oh, okay, we're doing things this way now, and it doesn't really, like, from my perspective, it just seems like, you know, a change for no reason. But you know, for the folks consuming the API, I think that's where a lot of the benefit comes from.
I poked at it what probably feels like 5 years ago now, and for me it kind of felt like I was using JavaScript and it seemed like there's a lot of kind of boilerplating type stuff, and I lose my patience with that pretty fast.
Yeah, you know, a lot of in the JavaScript world, this method that I had here of defining the schema by typing it out in a file like this, it's not common. People who work with the official JavaScript library will do boilerplate code, and it's a lot of it, and it's very verbose. And I inherited a project like that, and perhaps the first thing I did was replace all that boilerplate JavaScript with the plain text schema file, and it just made it a lot easier to work with and understand. But
yeah, I've been. Oh, go ahead.
Oh, go on.
I've been looking at. I mean, what's interesting to me about GraphQL is using it more internally, where kind of the data structures are a known quantity on the server and the client, and you know, a lot of, at least on the .NET side of things, it seems like a lot of the cool things that are out right now are sort of bleeding edge. But looking at there's the hot chocolate and strawberry shake frameworks, where like you basically can have you can expose just like a iQueryable of a type, and it will generate the GraphQL interface for that iQueryable, and based on the type, and you can decorate the type with like some attributes if there's, you know, I think for what we do, most of what we do is like CRUD level things. Generally, we're not going nuts with really deep trees and things like that. But yeah, it's kind of interesting to be able to express a query in such a way that you know, we're not having to hammer the database, you know, just to get a few things out of it, and also not write a ton of code to you know, in the REST API to do that level of filtering that you might need. So yeah.
What are your thoughts on kind of like a side-by-side implementation? Because if you think of like a normal line of business app, there's half a dozen pages that are cruddy, and then like 1 or 2 pages that are pretty involved.
I think it's actually very reasonable. In fact, I had to, at my previous jobs project, we had to provide a REST interface for a few things that would be consumed by internal services. But like that came about because the GraphQL API was so good. It's like, oh, hey, you've got a lot of data and you know how to get it really easily. Can you provide this in a REST, some of this data in a REST format? And like, I thought about it for a second. I'm like, fine. And what I did, and I'm actually like, this is another one of those things where it's like, I don't like cleverness, but this is good cleverness, is I just had I did an internal GraphQL query. So the REST endpoint was a query in the schema, and it just executed the query internally, took that response back, and then just shot it out to the client. Because I can look at that REST query and say, or the query that was being being executed for that REST endpoint, and say, here's what I want, and it's not going to change. Here's what I want. I don't know how to go get it, because the reason why the GraphQL API was considered good is because it had to talk to probably 100 different backend systems and data stores of various sorts, and it was just a complete and utter mess. And I was able to unify all that stuff in Clojure. And what I realized is, like, wait a minute, the REST API doesn't have to call all that stuff out directly. It can just run a query. It can just run a GraphQL query. And so I used it to do that, get all the data back, and hand off to the internal service the data that it needed. So sure, develop them side by side. But if you do it in that, if you do it in that regard, you can save yourself a lot of work. Actually, even one of my current projects is like, there's a particular mutation that we need to do that is tricky and involves, like, in order to avoid a race condition, going and fetching the latest version of a particular data. And I don't remember offhand where that data is stored, but I just, right before we go and do that, insert into or update in the database, we go and fetch the latest version of it, and make sure that it's good. And that is done with the GraphQL thing, because I don't remember where the actual data was. So I think that, like, it's beneficial. It also allows people to continue working with something that it doesn't require full buy-in. It allows them to continue working with something that maybe they're familiar with. And if you do it in that method, where that I described, where you're effectively using the underlying GraphQL system to front the REST API, or I guess to back the REST API, then that's also something where you can guarantee it's not going to change. If you accidentally add a new field to one of your objects or whatnot, you can guarantee you're not going to send it along. You're not going to surprise them with more or less data than they might have wanted. And so I think there's a good benefit to that.
I think it also just depends on how graphy your data is too.
Mm-hmm.
Like, ours is just pretty flat, and there aren't, like, the fancy connection type things just don't come up at all. But if we were in a different part of our data model, like some of the stuff that other teams are working on, then it could be like that ability to express that in a richer vocabulary would make a lot bigger difference.
I mean, one of the things that I'm working on now is you've just got, like, it's a PostgreSQL table with a bunch of large JSON columns and many thousands of rows, and we need filtering abilities, both to look into each of the JSON blobs and other attributes on that. And I use this to create effectively a richer filtering language than I could with query parameters. At that point, it's like, okay, well, we could, I guess, just make query. You could submit query parameters in a post body, but you're still you're still, like, creating your own language for saying what's what. Yeah. I said that, I had said initially that I felt this was a good way to implement a command query responsibility separation pattern. And that's, I mean, I feel like that's one of it. You're effectively separating out how you get the data from the things that manipulate the data. And it's something that I really like about it.
That's cool. Yeah, I think the thing that's most compelling for me is that however you feel about like opinionated systems, you know, GraphQL is kind of creating an opinion, or giving you an opinionated system for doing a lot of the kind of data access that everyone seems to want to reinvent the wheel on every time they're kind of creating a new project. And so, I mean, that is nice that, you know, if you're like, we just need to get to this data, and we don't want to have to build that API up, and, you know, because we're the only consumers of it. And as
Right.
everyone's kind of moving towards Jamstack and all that stuff, you know, yeah, that is pretty compelling.
One of the other things that I like about it too is that you're, by defining those relationships between types, you're kind of giving people something composable to work with. It was built for constructing screens effectively. This is the data that I need for my screen. I don't care I don't care where it comes from. Just get it to me. I don't want to have to worry about the mechanics of doing it. And as somebody who has spent a lot of time building screens or helping people build screens, that aspect where it abstracts away the mechanics of varying data, the data that is needed between the client and the server. I like that aspect of it a lot. Just having something declarative as opposed to imperative.
What are your thoughts on, so definitely for a larger team, it seems like it would add a lot of value. What are your thoughts on like a small team?
You mean on a small team? Or team or theme?
Team.
Team. I guess that, you know, that would depend, I think, on everybody's adaptability. You know, if you have flat data, if you don't need rich filtering capabilities, if you don't need to worry about data going back and forth, you know, and you want to use REST, go for it. If this, you know, if there's a use case for this where, but you have people who are very, I'd say, curmudgeon-y about not wanting to learn new things. Well, first I'd ask, why are you in this field? You have to learn new things all the time. But, you know, second, I might just say, like, well, you know, what is your objection beyond you don't know it, or beyond, like, you know, it is something new and different. You know, I don't know, it's not a panacea, nothing is, but for the use cases that I've had around needing to provide rich query interfaces, or needing to optimize data loading between, or data fetching between an end user's device and a server, I think that's been good for that. If it, you know, if people are on board with it, I don't know. I guess that comes down to team dynamics. I've worked with small teams where everybody has been really eager to try new things, and then I've worked with, like, the TypeScript developers who wanted me to send empty strings instead of null values because they didn't understand how to use TypeScript optionals. You know, and I think sometimes it's just maybe like, in their case, I had to go into their code and figure out what was going on and why I was throwing them errors when I gave them null values, or when a key wasn't in an object. And, you know, it's like, oh, you've misconfigured your compiler. And you know, in that particular case.
All right, is that a real thing? Like, you have to configure the compiler to support optionals? It sounds like a joke.
This was, I don't like TypeScript. I'll just leave it at that. A large part of why I don't like TypeScript was just based on my experience with that project and the people who ran it.
With C# now, you can turn on they call them nullables, but you can turn on, that in the compiler now.
I mean, like I'm dealing with Golang right now, and Go has what the concept of zero values. So you don't have nulls, you have zero values, and if you have an integer for whom a value is not provided, it's zero. A string is a null string is an empty string. There's no distinction there. And an empty array is also null. And so the REST endpoints that are on the project that I'm dealing with, it's like no results gets turned into an empty array, gets turned into null, which then the web server turns into a 404.
Part of the reason I was like, okay, I'm going to give GraphQL a chance is that we've been working with gRPC before that, and I was just like, it has optionals. I don't have to like, if I put a null in it, it's actually null instead of like magically getting turned into a zero. Oh my god.
Yeah. So like Go doesn't have unions, and yet like our data schema could use them, but there's, I don't know, you get creative. You can I forget what it is. You can bootstrap anything up to what I am at heart a Clojure programmer, and I have actually written like Clojure style lenses in Go. Took a lot of creativity to do that, but yeah, you find a way.
Life finds a way. I do have to say it would be awfully nice if the datetime type shipped out of the box, because literally every GraphQL developer on the planet is adding their own version of that. It's like,
it's not for. I mean, the JSON spec doesn't define one, so
yeah, yep. I like what they did with IDs though. That's a nice thing, because it's always like,
yeah,
UUIDs and datetimes are like the two things that just suck when you're dealing with JSON. It's like they found a pretty good solution for the ID one.
yeah. The pagination stuff is really nice. If I the current API that I'm working on, if I had to go do it again, I would have a single pagination field without a sort direction, and just like if you want the end of that collection, you specify last. Adding a flexibility in the sort dimension, it probably quintuples the amount of complexity that's needed in resolving that and sorting things.
Yeah, is there like a datetime standard that's becoming more, or seems to be more universal for that?
Well, I mean, like, technically those timestamps that were in that XML file were ISO 8601, but there's another one. It's a RFC time format that is the Golang standard, 3339, that I think it's technically a subset of ISO 8601. But like the GQLGen library that I use in Go, like if you define in your schema a time scalar, it will map that to a Golang time object, and then it gets formatted as a string as RFC 3339. The problem is, I think, is that maybe it's this 3339. I don't know. Whatever format it uses, it chops off the milliseconds, and I need that. And I'm getting the database, I'm getting the timestamp out of the database as a string anyway, and so it's converting it from a string into a time into a string. So I'm just going to, like, one of the things that's kind of on my plate soon is to just get rid of that scalar, that time scalar, that's the timestamp scalar, and just have it come out, have it just ship straight out of the database to the client that way, not have to do all that extra parsing and formatting work, and get my milliseconds.
Yeah,
it's hard to blame GraphQL for that when it's really a JSON problem.
Yeah,
Yeah.
that should be standardized because yeah, I'm sure.
Well, I mean, there are multiple timestamp standards. I think, you know, if I had to choose one, it would be RFC 3339 because I think the official spec, yeah, it does include milliseconds. And I mean, ISO 8601 isn't just a specification for formatting timestamps. It is like you can put in ranges, you can say time spans. It's complex and it covers more than just a single point in time. It covers a whole lot of things. Whereas 3339 is very much like, this is an instant in time with precision. You know, precision down to at least the second. Some maybe even a little bit further, but
Yeah, I'm sure. I'm just from the world of like ASP.NET, where you know that by default with the model binder will return the epoch as a date, and then it's trying to parse that in the browser, and then so if your browser's not in the same time zone as your server, you're screwed. And I mean, there's just like there's a lot of, I'm just like, yeah, that's just somebody should come out and just for JSON and whatever, just say this is how we do it now.
the problem with that is, you know, you've got 15 standards and none of them are good. So you write one to unify one. Now you got 16 standards. Yeah, I don't know. I like the scalars just more as clues for things, because they can be any kind of arbitrary data in there. It doesn't have to be a string. I have like one of my scalars in a schema that I have now is just it's called flags, and that is a map of like a JavaScript object or a map of keys to Boolean values. So this flag is on, this flag is off. It's just, you know, simple thing, but because you can't have arbitrary keys in a type. You know, it was either that or have an array of flag types where here's the name of the flag and here's its value. No, I want to look this up by name. I just can't define the names ahead of time. Those names don't belong in the schema. They shouldn't. They're defined at runtime. So my solution was a flag scalar. And you know, those scalars also, you can use them in inputs. There's nothing in the schema itself that defines like how it has to do. You have to do validation yourself. You have to do serialization yourself. But it's kind of like a way of passing data along where you don't know it's not well defined up front, perhaps, or can't be defined like using its primitives.
Awesome. Well, thanks, Matthew.
Yeah.
That was great.
Yeah, thank you so much. This was a great presentation. I'm going to go ahead and stop the recording and